Today, I'm going to explain how the transistor acts as a switch, and also I'm going to conduct an experiment, transistor as a switch using Proteus software. So this is the circuit I have copied from the Proteus. In this, I have used 2N3904 transistor. It can be used as a switch in this circuit. And when sufficient base and emitter voltage, VBE, it is applied, the transistor enters into the saturation mode and it will allow the current to flow from collector to emitter. So when current flows from collector to emitter, and the LED will be turned on. So this is the principle involved in this circuit. And the potentiometer, I have used 1 kilo ohm, and it acts as a variable voltage divider, which will adjust the base emitter voltage. In order to give the sufficient base emitter voltage, I am using a pot here. Pot I have used pot HZ from the Proteus software. And one SPST switch I have used to control the transistor operation, and by allowing or blocking the current to the base, which will block the current to the base or which will allow the current to the base. When it is turned, switch is in on condition, it will allow the current to the base. When the switch is in open condition, it will block the current to the base. And 1 kilo ohm resistor I have used, which will limit the base current in order to prevent the damage to the transistor. And here in the collector, I have used 470 ohm resistor in series with LED, which ensures the controlled current flow through the LED. So to limit the current flow through the LED, we have used 470 ohm resistor, and one DC voltmeter, which measures the base emitter voltage. You can use one more DC voltmeter between collector and emitter in order to measure the voltage between collector and emitter. So here, connect 5 volts DC supply to the potentiometer, one end of potentiometer and other end of potentiometer to the source, and connect the wiper of the potentiometer to the one terminal of SPST switch and other terminal of the SPST switch to the 1 kilo ohm resistor, and then to the base of the 2N3904 transistor, and connect the emitter of the transistor to the negative terminal of the power supply, and connect 470 ohm kilo ohm resistor to the collector, and another end to the cathode, and anode to the, and here I have used LED, that is BB LED, LED BB, which will turn on. Literally, you can see the color when it is turned on. If you connect normal junction diode LED, you won't get such color and all, and you will not feel the LED turned on or not. And connect the DC voltage source between the anode and the emitter of the transistor. Okay, so this is all about the connection. So when switch is in off condition, LED remains in off condition. When switch is in on condition, and the current flows through the base, and LED will be turned on. And so in order to measure the voltage between base and emitter, I have connected one voltmeter. In on condition, transistor in on condition, there will be approximately equal to 0.7 voltage drop between base and emitter. That is, I will show you. And in off condition, almost 0 volts between the base and emitter voltage. So now let us turn on the Proteus software. So already I have created this. I'll show you the output first, then later I'll show you how to construct. Now, and this, I have kept the switch in off position, and I'll turn on the simulation. So now the switch is in off condition and the voltage is almost 0, and the LED is in a off condition. I'll zoom it now. See, okay. Now I'll close the switch. Now the voltage I have applied is 4.5 volts because this is almost in the end point of the potentiometer. LED is turned on. Okay, so here I have used 10 volts power supply. Now I'll bring the wiper down. You can see here LED brightness is becoming low as my wiper is going down. It becomes low, and after some amount of time, it becomes off. See here. So when wiper is in the lowest position, the voltage applied from the source is 0.4 volts, LED is off. Now I'll increase it. For 0.65 also it is in off condition. For 0.7 also in off condition. In next step, the LED is turned on because it has got sufficient base emitter voltage, but the intensity of the LED is low. As I increase the voltage, 0.8, 0.9, 1, so the LED brightness is keep on increases. So from this experiment, you can understand when the voltage applied to the base is less than 0.7 volts, LED turns on. LED turns off. See, LED turns off. When you apply voltage more than 0.7 volts, LED becomes on. When LED is in on condition, when you turn off the switch, LED is off. When you turn on the switch, LED is on. Using switch also, when when transistor is in on condition, using switch also you can control the on and off. So, or when the switch is in on condition, by decreasing the base voltage also, you can turn off the LED. Okay. So this is about the experiment. Now I'll show you how to construct this. I'll close this project, stop the simulation, close the project. Okay, so click on new project, give the name of the project. I'll give the project name as transistor as switch. Okay, click on next, finish. So go to component mode, select B source, select B source, that is DC voltage source, place here. So I want to adjust the voltage. So this voltage, after clicking edit properties, you can give 5 volts. Click OK. Then search for potHG. Click OK. Place here. Connect one end of source to pot, other end of the source to other terminal of the pot. And here you need one switch. Select SPST switch, single pole, single throw switch. So I'll select this switch. Click OK, place here. One terminal of the wiper you connect to switch. So you connect one current limiting resistor. Select for resistor. RES you type, you will get here. RES. Select generic resistor. Place here. Adjust the value as 1 kilo ohm. Connect this here. And from this, we are going to connect one transistor. I am going to use 2N3904 transistor. This silicon transistor I'll use. So connect here. And from the resistor to the base. And from emitter to the negative terminal of the battery. I need one DC voltmeter to measure the voltage, DC voltmeter between base and emitter. How much voltage we are applying, that also you can measure here. Okay, then one current limiting resistor for LED. Connect here, rotate clockwise, and adjust the value as 470 ohm. You can give 1 kilo ohm also, but the brightness of the LED becomes low. That's why I'm choosing 470 ohm. Connect this to collector. And here you need LED. This is very, very important. Other LEDs, you will not get the feel it is becoming on or not. So select this LED BB. Okay, so connect here and collector to resistor, cathode to resistor. And from LED, I need one DC voltage source on the output side. Collect this to the positive terminal of the battery, DC source, and emitter to negative terminal of the source. Adjust this to either 10 volts or a 12 volts, because 5 volts the LED will not become on. Now everything is over. I need to connect one ground to the emitter. Drag this. Okay, connect this to the ground. Okay. Now circuit is ready. Now I'll turn on. Switch is in off condition. I'll close the switch. So I'll bring this wiper down. See, so for lower voltage, LED is in off condition. As I increase my voltage, after 7, the LED is becoming on and the brightness also increases. So if you want to connect 1 voltmeter also, you can connect 1 voltmeter between collector and emitter just to analyze it. So when it is in off condition, when you give lower voltage, almost all voltage, it will appear across between the collector and emitter. See, when the wiper is in lowest place, almost all voltage is appearing across the collector and emitter. And since this is off, and we will connect one more DC voltmeter across this LED. How much voltage you can feel it, measure it. Now turn on. So when input is 0 volts, so almost voltage is appearing between collector and emitter, and remaining voltage is appearing between anode and cathode of the LED. Now when you increase the voltage, LED turned on, and it requires 2.2 volts to drop takes place across the LED, and the voltage, now transistor is completely turned on. The voltage between collector and emitter is 0.67 ohms. So in this way, you can use transistor as an switch. This is a very important circuit to understand the transistor operation when it acts as a switch. I'll stop the simulation.